My name is Dima El Zein, and I'm a PhD student at the Université Côte d'Azur and the Laboratoire I3S in France. I had a pretty classic education. I did my bachelor and my master's degree at the Lebanese University before moving to France for my PhD. And I'm happy to be here because I'm going to share with you a subject that is a part of my thesis project and that I find is really interesting because it interferes in our everyday life. So as we know, we are most of the times either on our phones or on our laptops, and whenever we need an information, the access for it became very, very easy because of the existence of search engines or information retrieval systems. And so I assume most of you know how to use a search system. I'm gonna start by introducing the problem and let us say the need for the subject I'm going to be introducing. So first, I was suggesting you to propose some query or queries, if you have many, to know what is the date of birth or birthday of Johnny Depp. And I think we already had some previous questions, some previous answers.
Yeah, it was straightforward.
That was pretty straightforward, saying that the date of birth of Johnny Depp, and also the answer was pretty straightforward. Because search engines are optimized to propose immediate information that are fast and that serve short answers. And sometimes they show first the paid ads because that's one of the source of their income. The challenge is when we want to go further or we have a learning task that we are interested in. And let us say we want to know how did the first wave of COVID affected the food prices and agricultural feed in Europe. And this time, the query is not pretty straightforward. So I have to enter different queries. Let us say impact of COVID on agriculture, impact of COVID in Europe, first wave. So it's not because we do not know how to search, but because we know in advance that search systems are not advanced a lot to understand complex queries. Let us say I entered, no matter what was the query I entered, I will not have a straightforward answer because it's a complex task. And the information returned here will be more or less the same for all the users. So for me, even if it was a senior person, a child doing the search from Lebanon or from France, we will have pretty much the same results. And because they are not personalized to me, to what I know. Maybe I'm a data scientist. I don't know anything regarding this field. Or maybe I'm an economist. So I need some advanced subject. So the problem we'll be discussing today is that search systems are not yet optimized for open-ended queries, for complex queries, and they do not care whether I will learn something or not, because they do not know what I know. So they do not account for you, neither your knowledge, and they just propose the information for you, and it is your task to change your query or to hop from one page to another in order to receive the information you might need. So I showed here the first 3 results that were reports from different web pages, and I scanned them like very quickly, and I noticed that the first document has information that I already read in different documents or in previous queries. So I kind of wasted some time on reading a document that contains an information that I already received it in some other results. The second result has redundant information with what I already know, because I already attended a talk before, because I'm an expert in this field. So I also wasted some time reading some information that I already know. And the third result had new information, but it was too advanced for me. So I also wasted some time to read some information that did not adapt to my education or to my knowledge level. So the cost for me to reach the needed information will be first to change the query Sometimes it can go up to 5, 6, 7, even 10 queries. And sometimes we have search engines that will start helping us to formulate our query, but it's still some wasted time. And I have to check one page after the other. And while hopping from one page to another, I will have information that is pretty similar or that I already know. So that is not really adapted to me. So I will spend some time, and sometimes I will just lose motivation and I will say, okay, it's maybe too complicated to learn about this topic over the internet. Maybe I will go take an online course. Maybe I will go attend a talk. I will talk to an expert during a face-to-face conversation. So I will give up on finding this information on a search engine. So I am not saying that search systems are good, but I'm not saying that they are bad as well. It really depends on the task and on the type of information we are looking for. For example, we have already some work in the literature that divides the search activities into 3. Lookup, that are mainly the first example of date of birth of Johnny Depp. So it does not, it's a fact. The fact doesn't change. And it does not need to be personalized, whether I have a bachelor degree in computer science or whether I have a PhD in economics. So this is the first one. The second one is learning, and the third one is investigating. The focus of our talk today will be the need to adapt search systems to make people learn while using search systems. So it's using search engines as a technology to learn rather than a technology just to retrieve information. And here I am introducing the topic of search as learning. And I think the name is already, it explains what does it mean. It means that I am using this tool, the search system, to learn and to change my knowledge. And by definition, learning, disregarding of computer science, of search engines, learning, what does learning mean? Learning means it's a change in knowledge. And if I want to change the knowledge of someone, let's say I'm giving a course in a class, I have to know first, what is their background? Like, what do they already know? And then I will adapt my course accordingly, according to this knowledge, according to this education level. So before I decide that I want to change the knowledge of someone, I must know what is their previous knowledge. And this is most of the time inspired from human interactions. So I will give an example that that is customized to people in Lebanon, but I hope that people outside Lebanon will also understand. Otherwise, I can explain. So let's assume we have a human interaction between 2 people. The first person is asking about the Ghandour company, is asking, what is the Ghandour company? So the other person asks, do you know Unica? Apparently, this girl knows Unica. So my answer will be pretty straightforward, that Ghandour is the manufacturer of Unica. Now, if I want to change the scenario and I want to say that I have another person who also asked for the same information, that is, who is Ghandour, but in this time, he doesn't know what is Unica. My answer in this case will not be suitable to say manufacturer of Unica, because he doesn't know who is Unica. Although for me, like every person on earth must know or must at least try Unica, but this poor guy haven't tried it yet. So my answer, although the question was the same, my answer should be adapted to this person. So in this case, it would be, it's a food processing company founded in Beirut that produces Unica, and I can elaborate as much as I can. So next time, this same person, if he asks me about Tarbouche, I will ask you to write in the chat, what do you suggest the answer will be? Do you think it will be detailed? Do you think it will be short? As a human interaction, assuming it was an interaction that happened in real life. I think this time I can see the chat.
You can also unmute and interact if you want.
Yes, you can
People
unmute
that
and
are on
interact.
Zoom,
Yes.
not on YouTube. Yeah.
Yes. Okay, I can now see a Arabic for Lebanese speaker. Yes. But I have to take into consideration this time that this person now knows about Randur and knows about Unica. So my answer to be adapted, it can be the manufacturer. It can be, I can say Tarbush is another product produced by Randur. So in this case, I adapted my information and I updated my beliefs about this user, that this user knows now about Randur. So if I want to look in more details, and thank you, Sarah, for your suggestion. So I have this person who was answering, let's assume it was me. I have my beliefs about the girl, and I have my beliefs about the knowledge of the boy. So I know that the girls know about Unica, and I know that the boy doesn't know about Unica. When they ask me for Randur, and I will give them the information, I will update my knowledge about them, and I will assume that also now both, they know about Randur. And this is how it happens in real life, like during interaction, I get to know what other people know, and based on that, I adapt my answer. It's item manufactured by Randur. So if we go back to the classical interaction between the search system and the user, I have a user who is submitting a query who has an information need. Submits the query to the information system. This information retrieval system is returning a search result page that has different results. And the interaction on the other side will be that the guy will select one of the documents and will read them. And here I can assume that the document the user read is his source of information, because that's how also we evolve. So what I will do is that I will extract the information inside this document, and I will say, okay, now this person, this user, knows about the information inside this document. And it will be a loop. Every time he will submit a query, he will read the document. I will extract the knowledge inside this document, and I will update what I know about them. So here I have the search system that thinks that the users know about this, and it will repeat every time the user will read a document. I'm saying document now, but it can be a video, it can be an image, but to simplify the example, we will say, or we will assume that the result is text. So RAD, is it considered as a recommendation system which is already implemented? It's a yes or no, because recommendation systems is a subfield of information retrieval. The main difference between information retrieval and recommendation systems is that in information retrieval, the need of the user is expressed using a query, while a recommendation system that is, let us say, Amazon, Netflix, you must recommend, or sometimes even, I don't know, if you are buying anything online now, you have a recommendation system. In that case, we are suggesting some products to the user without even them asking for them. So if you go to Amazon, you might not necessarily write for something, ask for something. It will by itself start proposing something to you. And it's not the case in search systems. In search systems, if you open the Google, let's say, you will not have any content proposed to you. You have to ask for the specific information you need and then wait for something to be returned. I hope I have answered your question, Raed. But it's a similar. There's many common things between the two domains. So now that we have assumed that the information inside the document is the user's knowledge, it's time to discuss what are the challenges. So the first challenge is that how should I represent the user's knowledge? So, okay, I know that this text is the user's knowledge, but what does that mean? How do I save it? I have an information system that understands, let's say, binary things or vector things. How should I tell this machine that this user knows this information? So first is how to represent the user's knowledge. Second is how to measure that, okay, he has knowledge, he went through the internet, he read some document. Now, how do I know if he learned, yes or no? Third is, now that the search system is aware about the user's knowledge, how should I adapt it? How should I personalize the results to all the information I have about the user? And fourth, that is the most important thing for researchers, is the designing of experimental studies. So in research, usually we propose many theoretical stuff, but we have also to prove that it works, that it reflects reality. So we do some experiments on real users. So we will elaborate each of the ideas, and do not hesitate to interrupt me, to send to write your questions. So to represent the user's knowledge, I have different proposed methods that will transform the text or the document into a numerical representation that will be fed to the machine. So I have a module that will, I named it content extractor, that will do some text mining or some natural language processing to extract the information inside this document. I am proposing 4 different methods, but that does not mean that those are the only 4 methods. And that does not mean that one is right or another is wrong. We are still exploring them. We are still exploring what are the inconveniences and advantages of every single one, and which one represents better the real user knowledge. So to start, we can represent them as keywords or as triples or vectors or embedding or graphs. And I will show you some examples. So I went on Wikipedia, assuming that I am a user that read this article about Apple. And then I want to extract the knowledge inside it. If I want to start from the simplistic way, I say I want to represent them just as keywords. There are many different methods in case we want to talk a bit of the technologies used. We have TF-IDF, we have RAC, we have YAC, we have many different other methods that will extract the important keywords, and that will help me say, okay, now this user knows about Apple, knows about computer, American, international, multinational, United States. But it's a bag of words, and sometimes they have some weights, but there is no relation between them. I just know that this user knows about this concept, but I do not really know if he knows that California is in the United States. What does he really know? But it's still a good way to start this representation. The next proposed representation is triples, and those who are familiar with the ontology field might maybe can relate. And for those who doesn't know, it represents sentences or facts by triples. So subject, predicate, object. In this case, for this task, I just took a screenshot of a small part of it. I have that Apple is an industry in technology, Apple is an industry in consumer electronics, Apple's headquarters in California, and etc. Okay, so this is not my code, this is just a screenshot of an online commercial tool called Diffbot that you can try. But I thought it's better to have a better visualization than to show you some boring Python code. The third method is vectors, and I think that you are more familiar with this type of representation, especially with BERT now, but it's not just BERT, it can be Word2Vec, Doc2Vec, BERT, or SBERT. They have many different ways to represent sentences or text as vectors. No matter what was the chosen method, the result will be will have the same format, will be a vector of numbers expressing this sentence. And the last method is knowledge graphs. To do knowledge graphs also, you will notice that for all the method, there is a lot of work in natural language processing. So specifically for knowledge graphs and for triples. So in case you see here, we have the tag on the text. So there is named entity recognition. There are some cleaning, the text cleaning, removing the stop words, some co-reference also, if you are familiar with that. So just for you to know that it's an information retrieval field, but it's very related to the advances of the natural language processing. So as much as the NLP fields gets advanced, the more it will help us really to better do our representations. So the result of this will be a knowledge graph that say that, okay, Apple is a technology. So we can, So we can see here that the information is more linked between each other. And that's something we are currently working on. We are exploring the feasibility of it. And you can see here, if you want, the online trial of the tool. So that's what will happen every time the user will read the document. No matter what was the chosen representation, this representation will get updated with the new content. So this is the representation for the first document I read. If I go and I read another document, the information will be extracted and this knowledge graph will be updated. Now I have a question. About this question, I have already the answer for it, but I would like to know your opinion, or what do you think? I am assuming now that when the user is reading a text, he or she is taking or acquiring all the information inside it. But there are different factors that might affect the knowledge acquisition. So if we are two people, that read the same document, do you think that we will acquire the same knowledge, that I can have the same representation of their knowledge? Yes or no? I would like to know your opinion. And why, for sure? Like, what are the things that, well, absolutely not, okay. Can you just let me know why do you think they are different? What might have different perspectives? Mm-hmm. Because each one of us might think and understand another way. Yes, both answers are right. Other suggestions? For example, tarbouche for Lebanese people is different. Yes, that's because Lebanese people have different previous knowledge. So yes, it's true. It's true, and all the answers are correct. I have some more answers to add. The factors that might affect our knowledge acquisition, first, because we have different backgrounds, because, is it not changing? Yes, because we have different backgrounds, because we might not have the same learning rates. So even if we are in the same class, we have the same age, maybe I understand things by reading way better or way less than other people. Also, there's also a factor that the time I spent reading this document, I cannot assume that just because I clicked on a result that I acquired all the information inside it. So I also have to take into consideration the time this user spent on this document. There are also many researchers studying the user's behavior while they are surfing the web or looking at results. So they look at their mouse movement, at their scrolling behavior. So some researchers might prove that if you scroll very fast, it means that you are learning faster. Other researchers also, they try to track the eye gaze. So they track your eye movement while reading, and they will extract, let's say, the proportion or the part of the document you read. Maybe you saw, you went to a Wikipedia page, but you did not notice the images on the right. So I cannot assume that the images on the right are acquired knowledge. And there are really many different factors acquiring affecting the knowledge acquisition. And I think you already like understood the concept. For now, we will assume that all those are fixed factors, and we will assume, just for simplicity of the rest of the presentation, that if I read the document, I will extract all the information inside it. But keep in mind that in real life or even in research, we do take into consideration other factors. So now that I have tracked the user behavior, I have tracked the result they have read. Yes. Hassan? Okay, it's okay. Now that I'm aware about the user's knowledge, it's time to personalize or adapt the search systems to this knowledge. How do I do? I have on the right my representation of the user's knowledge, no matter what was it. And I have on the left the new document to be proposed. So the user wrote a query, and I want to propose a result or a document. It's now time to decide whether I want to present this document or not. So what I do is I also extract the information inside this document, and for sure it should have the same format of the user's knowledge, and then I compare them. And here the comparison method might be different from one method to another. So if I'm comparing keywords, we will have, let's say, simpler methods or simpler mathematical functions to compare. But if I'm comparing embeddings or word vectors, then one of the very common methods to compare vectors is the cosine similarity. So no matter what was the chosen, each of the chosen format has its own similarity formula that will tell me whether this document is similar to the user's knowledge or not. Now, my question for you, do you think the similarity should be high or low? Or what do you think about the returned? What should I return? I have a document, I calculated the similarity with the knowledge, and I have a number. If this number is too high, what does that mean? If this number is too low, what does it mean? Raed is saying, depending on the information we have about the user. Okay, can you elaborate? Can we say the weight or the importance of the word? Okay, thing is that now if we want to take the simple representation that is keyword, the user's knowledge is a bag of words, so it's many words, and the document is now another set of words, and I have two bag of words that I want to compare. I had some similarity function, and I calculated the similarity between this set and this set. If the similarity is high, what does that mean? And if the similarity is low, what does that mean? You can also participate by speaking if you want. So the answer is, when the similarity is high, it means that the content of this document is close to the user's knowledge. And when the similarity is low, it means that the content of the document is different than the one we are proposing, than the user's knowledge. So here there is a compromise to be done, because if I propose something that has a high similarity with the user's knowledge, it means that I am proposing something that the users already know. On the other side, if I'm proposing a document that has a very, very low similarity, it means that I'm proposing a document that has novel information. So there's a compromise to be done, whether I want to propose something that is very close or very similar to the user's knowledge, or very far, and in that case, I am risking to return some document that is not even adapted to his education level. So let us say the machine already knows that I know about honey, and there was a document about horses. When it calculates the similarity, it will see that the similarity is very low, and it will say, okay, it's a novel content, it's something the user does not know, and it will return it to me. although it's the new information, but it might not serve me because it's totally different than what I already know. I will read the chat. I mean, if I will take some time later to read them. So now this is the updated workflow. I have a user that submitted a query, and you can read it from, you can start it from whatever you want because it's a loop. So I will start from above. I have the user who will submit a query to the search system. The search system has already some knowledge about the user. Before it returns the document to the user, it will calculate the similarity and take a decision, make a decision whether I want to return this document or not. And then it will return a filtered search result to the user. The user will select one document. I will extract the content of this document and I will update my knowledge. And it goes into a cycle. Every time the user issues a query, I filter the documents, I return them, the user reads one, and etc. So that is the proposed framework. That is, let us say, the theoretical framework to make machines, search systems aware about the user's knowledge, how to represent the user's knowledge, and finally, how to adapt and personalize the results according to this information. So before I move to the experimental design, I would like to know if you have some questions or something to discuss. Okay, so I will move to the last part, that is the experimental design. So now I have proposed this theoretical over here, Nada. Okay, amazing. Thank you for your interaction, by the way. So I have proposed this theoretical stuff, and I want to prove that this is the right way to do it, because I can propose anything. I can propose any formula, any method, but there is some experimental things to do to ensure that I am doing it right, and this really reflects the user's knowledge. So first, to do my experiments, I need some data. And the data for this type of experiments is gonna be, and I tell you already that it's very difficult to find this type of information because previously because this is a new field, and researchers have different interests. Before, they were focused on retrieving the information in an efficient and fast way. And now search as learning is becoming really a hot research topic. So we have some difficulties to find some data sets to do the experiments. But let us imagine what would the data set I would need to prove that my framework is working. I would need some data that contains the knowledge of the users before the start of the search session. I need the data logs. So what queries did they issue? What documents did they see? How many time did they spend on each page? How many queries did they change? So all the search logs. And finding the logs is not difficult at all. Like, we can find a lot of such data, but the challenge is to find this data coupled with some information about the state of the user before the search and activity and after the search activity. And this is the challenging part. So because we have some limited amount of data, we often do our own experiments with some real users. How do we do it? We give our users some task. We tell them, okay, today you will do some search about Python programming or about the economic crisis during COVID. We give them a very specific search need. Before they start the search session, we measure their knowledge state. I will discuss later how can I measure this, but let us assume for now that they will do an exam, and this exam will be graded. So I will measure their knowledge before, and then I will give them some time to do whatever they want on the search system. They issue the query they want, they read the document they want, and meanwhile, I would be tracking their behavior and collecting the data about their behavior. After they finish, I will also measure their knowledge after the search activities. And finally, here the experiment is done, and finally comes the data analysis and the behavior, and analyzing the behavior of the users to really understand this user did not know this information. He did his search activities, now he knows it, or now he changed, his knowledge changed, or he read this document, but his information regarding this information did not change. And here there are a lot of exploratory activities to do whenever we have the proper data, and it's really difficult to find some big data, like more than 200, 300. I don't think I have worked with anything bigger than this for this type of data. And then we do the analysis. So one of the methods to compare or to measure the knowledge gain, the real knowledge gain, the first one is that I give my users some exams, like true, false, or question à choix multiple. I forgot the name in English, but you know, like the question, you have different answers for them. So it's a type of MCQ, yes, multiple choice questions. Thank you. So they do this exam before the search activities and after, and then I compare the score. So before they had a grade of 12 and now it's the grade of 20, I will analyze the documents they read and I will understand how and why. The second idea is that also there are many researchers that worked on that, is that they make the users write some essays. So they tell them the search task will be learning about horses. Write a small essay about everything you know about horses. They do the search activities and then they rewrite the essay and then they compare. But here it's obvious that it's more difficult because there is more analysis to do on the text, but it's also an interesting job to do. They often look at the vocabulary they use. So if the vocabulary changed during search, if they had more complex sentences, and etc. And one of the other methods, those are also not the only three methods, but the most common ones, is that they ask the user to draw some mind map. So to organize their knowledge about a certain subject using mind map. It's interesting. Many researchers did it, but there's still a challenge to measure the difference. So for example, here I have the knowledge before, I have the knowledge after. How should I really quantify the change after and before? There are some work done on that. And one of the recent, or let us say modern way also to measure the user's knowledge is the online education platforms like MOOCs. Or we have so many EDX, so we have data camps, but many were done on MOOCs. And they said, okay, this way we can log the user's behavior. We already know what is their level before, what is the level after. But the challenge here is that you cannot guarantee the user's commitment, because I think most of us or all of us have started some courses online and haven't finished them yet, or do like one chapter every 1 month. And some other people, I see people laughing in the chat because it's true, because there are no obligation. It's a personal motivation. So that was one of the main challenges when researchers used online education tool to measure the user knowledge. Otherwise, they had to force them, they had to pay them, or they had to hire some users to do the experiments. I see that it's a very interesting field, and maybe I proposed problems more than I propose some solutions, but I see that that's very normal because that is the research. And otherwise, if it has been easy, or if we had already all the solutions, it wouldn't have been a research topic. So bear with me if I could not answer like all the questions I propose in this talk, but the idea was to really give you an overview about the limitations of search systems in education and to introduce you to the search as learning field and to make you like just think beyond of just programming or just replicating the other projects, but really thinking how to make research advanced. And it's a really interesting topic, but it's a really difficult topic because it has different fields inside of it. So it's not just information retrieval, it has education. So we have already many research on education that try to understand how children in classroom or how adults acquire their knowledge. So there's an inference with this field. Also psychology, like why do different people receive information differently? One also of the aspects that are being studied in this field is the memory loss, because when I read some information, I retain some, but with time, some information might be erased. So when representing the user's knowledge, I might also consider some facts like those that I might forget. So after a while, I might consider that to start erasing some part of my knowledge. And finally, I think you noticed that there is a lot of intersection with the natural language processing field. So that was it for me. I hope it made you think a little bit outside the box and introduce you to this new field. In case you have any questions, do not hesitate to drop them in the chat, and also do not hesitate to reach out to me in case you are interested to work in the research field for sure. And this on this topic, whether you're looking for a PhD in this subject, or we can discuss further. So thank you for your time, and I'm looking forward to read your questions.
Thank you so much, Dima. It was a really interesting topic, and definitely please ask your questions if you have any. And as Dima mentioned, if you want to continue our research topic, this is a great one to dive deeper into it. And Dima will support you, definitely.
Thank you.
So let us know if you have any question, and let's say a big thank you for Dima. And we'll share with you the link if you didn't catch up the recording from the starting of the webinar, you could watch it again. Thank you, Dalia. Thank you. Very interesting. Okay, cool.
Thank you. Thank you all. Yeah.
Great. So if you don't have any other question, then we're done. I'm checking on YouTube. Okay, thank you very much. This was very interesting. Thank you, Radi. There are some users, I don't know their name. Thank you, Rihab. Thank you, Raed. Okay, great. Thank you, Dima, and we'll chat soon, of course.
Sure. Thank you, Larissa, and thank you, everyone.